So the table here is telling me that if I take 3,649 and I divide by 138, that it's going to go in 26 times with a remainder of, and I got to fill in the remainder. So I'm just reading that first line there. So now I got to whip out a calculator to help me. How would I do this on a calculator? So 3649 divided by 138. 3649 divided by 138. So there I can see the 26 times. So the way to do this, to figure out the remainder on a calculator, is we take that number and we subtract from it the 26, because we just want to know what that fraction is. Now, to get that fraction, we divide it by 138. So what I'm going to do on Desmos is go parentheses and multiply by 138. And that says 61 should be the remainder. Okay. Other ways to come about that would be to take, we know it goes in 26 whole times. So if we take the original number, 3649, and we take away from that 138 times 26, that should tell us what the remainder is. So there's several ways to go about doing it on a calculator. So we get a remainder of 61. Oops. So then we just keep going. So then we move the divisor up to the dividend, and we move the remainder up to the divisor. Now, if you remember that Euclid's method always moves the remainder up, then that means this table shows all of the remainders here, right? The next divisor is always the previous remainder. So this 61 must have been there, and this 16 must be there. Let's double check that. So if I take 138 and divide by 61, computer here claims that 61 goes into 138 twice. And as far as the remainder goes, the claim is it's 16, right? So if we take 2 times 61, that's going to be what, 122? 138 minus 122. And again, the 122 is 2 times 61. I'm checking the division. That's going to give me 16. Yeah, 16 is definitely the remainder. And again, Euclid's method always, the previous divisor always moves up, and the previous remainder always moves up. So there's the previous remainder. And so this previous remainder must have been 13. This one must have been 3. This one must have a remainder of 1. And finally, I get the remainder of 0. And that 0 tells me that the previous remainder has to be the greatest common factor. So this tells me there are no significant common factors between these two numbers. The greatest common factor, 3,649 and 138, is 1. And whenever 1 is the greatest divisor, right, that's not a big deal, that they have really nothing in common. These two numbers are said to be relatively prime because they have no factors common to each other. All right. So this problem was a lot easier than it looked because the way Euclid's method works is the previous remainder is always the next divisor. Let's try another one where we don't get all of that information. It's a little harder.